Hey A&P students, welcome to lab number 2, Anatomy and Physiology 1, lab number 2, which is all about body regions, as you can see right here, as well as body cavities. So today we are going through body regions and body cavities. I got this picture up here, which is actually a picture straight from your lab manual. It's on page 12 of your lab manual if you want to check that out. And it is going over, not really going over, but pointing out the anatomical names for different regions of the body. Now, a lot of these you are going to be totally familiar with. Some of them might be a little bit new, okay, but a lot of them you know already. Now, let's run through these really quickly. And actually, if you look on page 13 of your lab manual, there's a table for you to fill out where you describe these regions kind of in your own words. It's actually one of your homework assignments to fill out that table. So you might want to pull it out and kind of do that as I'm going through this. All right, let's start then. The first one that we're going to do is the orbital region. So orbital region is, of course, around the eyeball. It's the eye and its immediate surroundings. Then nearby we've got the mouth, which is the oral region. We've got the cheek, which is the buccal or buccal region. Go down a little bit, we got the cervical region, which is the neck. Keep going, we got the shoulder. Shoulder is the deltoid region. If we jump over a little bit, we got the chest. The chest is the pectoral region. The armpit is the axillary region. The arm, so think about below the shoulder but before the elbow. The arm there is the brachial region. Then the front of the elbow is the antecubital region. And we're going to kind of skip the forearm and the wrist and jump down to the fingers. Fingers, of course, are digital. All right, well, what else do we got? We're at the middle of the chest where the breastbone is. That is the sternal region. The breastbone is the sternum, so it's the sternal region. Then we have our abdominal region, and right smack dab in the middle there, where we have the belly button, that, of course, is the umbilical region. If we jump around to the back side here, the lower back is the lumbar region. And then kind of below that, think about like right above the gluteal cleft here, that is the sacral region. If we jump back around to the front, we've got basically the groin where the thigh meets the trunk. That's the inguinal region. Both sides, of course, there. A lot of these are on both sides. Not all of them, though. And then in between, above the genitalia, we've got the pubic region. The thigh is going to be the femoral region. The front of the knee, where the kneecap is the patellar region, with the back of the knee being the popliteal region. Toes are digital. Then the bottom of the foot is the plantar region. So you got to know all these regions, and we'll encounter these regions throughout A&P 1 and A&P 2. You also should be able to describe them in relation to one another. Like, for example, the example I give here, the brachial region is proximal to the antecubital region because brachial is closer to the attachment here. Antecubital would be distal to brachial. Pectoral will be lateral to sternal, and so on. So definitely go over these. Fill out that table on page 13. That is one of your assignments. And with that, let's talk about body cavities. So we just did something on the outside. Now we're going to move and do something on the inside. We have major body cavities where we keep our organs, okay? We keep our organs inside body cavities. Now, there are two big body cavities. One more towards the front and one more towards the back. And by the way, this picture I'm showing you here is from the top of page 15 of your lab manual. So you might want to flip to that page so you can go through it as, and look at it as I'm describing it. So there is a cavity in the back, and it's colored with the darker gray here. This cavity in the back is called the dorsal body cavity. And it actually consists of two parts. So dorsal is going to be composed of a superior part called the cranial cavity, which is in our skull, very well protected. And of course, we're going to find our brain here. And then we've got our vertebral cavity, which runs down through all of our vertebrae, through our vertebral canal, and of course, houses the spinal cord, and we'll find spinal nerves in there as well. So that is our dorsal body cavity. What else could you call it besides dorsal? Well, you could call it the posterior body cavity. If you remember how those terms were synonymous, we learned about that in lab number 1. So cranial cavity with the brain, vertebral cavity with the cord, and those two combined make up the dorsal body cavity. Now in the front, in the lighter gray, we have the ventral body cavity, also known as the anterior body cavity. And it is separated into two big parts. And I want to point out this muscle right here. Let's make that line a little bigger. If I can do it. There we go. There's a muscle right here. That muscle right here, you use it all the time. It is very much involved in breathing in, and it is called the diaphragm. The diaphragm. And that diaphragm right there, that inspiratory muscle, is going to separate a cavity above, the thoracic cavity, from a cavity below, which is called the abdominal pelvic cavity. And the abdominal pelvic cavity actually has an upper abdominal portion and a lower pelvic portion. And there's no dividing structure separating these things, but we do speak of them as two separate regions. All right, let's kind of jump back for a second, go over these things again. We're doing the ventral body cavity here, which has a muscle stretching across of it, and superior to that muscle we have the thoracic cavity, and of course that muscle is the diaphragm. The thoracic cavity is going to house the lungs, the heart, the esophagus, the trachea are going to be found in there as well, major blood vessels too. The abdominal pelvic cavity is below the diaphragm, inferior to the diaphragm. It's got a superior abdominal portion and inferior pelvic portion. The abdominal portion is going to hold your stomach. It's going to hold your liver, your pancreas, good chunks of your small and large intestine, kidneys as well. Your pelvic part is going to house things like the urinary bladder. It's going to house the large and small intestine again. It's going to house some female reproductive organs as well. So a lot of internal organs here. Now, what do you think? Is this ventral cavity as well protected as the dorsal cavity? No, it's not. The ventral cavity is not as well protected. It doesn't have as much bone around it. Now, of the two chunks, thoracic versus abdominal pelvic, which do you think is better protected? Definitely thoracic. It's got the rib cage, it's got the sternum, it's got a lot of good musculature. The abdominal pelvic cavity has less protection, especially the abdominal cavity. And that's kind of okay when we're thinking about quadrupeds. That's a cat right there. Because you're not often going to get, attacked underneath like that. So it's all right that it's not like the most protected area. Humans, on the other hand, we are upright. So we are kind of like putting this unprotected region front and center. Okay. Let's keep on moving. Got some good cavities here. Let's take another look at them and break them down even further. So just to recap a bit, I can still see my cranial cavity right there. I can see my vertebral cavity right there. And those, of course, make up my dorsal body cavity. And I can see the whole entire ventral cavity right there. Going to put a circle around the whole thing. I lost it a little bit there. It's okay. So there it is. Let's get rid of all that. Now what we can see here, we can see that diaphragm stretching right here. Diaphragm's right there. Separating the thoracic cavity, superior to the diaphragm, from the abdominal pelvic down below. And now what we're going to see is we have other cavities within them, okay? Within the thoracic cavity, at least. And we'll get to the abdominal pelvic a little later. We're doing thoracic right here. So, what I want you to notice is that there is a lung right here and there is a lung right here. Each lung has an associated cavity called the pleural cavity. Each lung is associated with a pleural cavity. Okay? So, each lung is associated with a pleural, I can't type today, pleural cavity. There we go. Notice, I want you to notice something that I did not say, okay? The lung, there we go, the lung is not in the pleural cavity, but it's associated with it. This is an important distinction. We'll expand upon this in a moment. Now, in between your two lungs, there is a region. So there is going to be a region in between the two lungs. In between the two lungs, there is a space. And that space in between the two lungs, is known as the mediastinum. So I can see my entire mediastinum right here. I'm going to outline that guy in red. There we go, kind of like a vase right in between the two lungs. There it is, right there. Anyway, space in between the two lungs is the mediastinum. We're going to find the esophagus there. We're going to find the trachea there. We're going to find the heart there. And the heart is associated with its own cavity. The heart is associated with a pericardial cavity. And again, we're going to make that distinction where we're going to say the heart is not in the pericardial cavity. It is associated with it, but it ain't in it. And we'll expand upon that distinction in a moment. All right, so let's backtrack for a second here. We had the dorsal body cavity up top here. Here's the dorsal body cavity. And up here, I'm going to put a D right there. I'm going to put a D right here, dorsal. Then we can break those guys down. We've got the cranial cavity and we've got the vertebral cavity. Okay? And then this entire guy right here, bum, bum, bum. I know I'm not perfectly in the line. Forgive me. This entire guy right here is the ventral body cavity right there. And the ventral body cavity has the diaphragm, that muscle running along the middle. And above that diaphragm, we've got the thoracic cavity. Below that diaphragm, we got the abdominal pelvic, and we see the abdominal part and the pelvic part. And then we broke down the thoracic cavity more. We said on each side there was going to be a lung, and each lung had an associated pleural cavity. We said there was a middle chunk right there. And that middle chunk is the mediastinum. In my superior mediastinum, I'm going to find my trachea, my esophagus. In my lower mediastinum, I'm going to find my heart. And the heart is associated with a cavity called the pericardial cavity. Okay, this is all very good. Got another picture here where you can kind of see the same distinctions that I was just making. So take a minute, take a moment. If you haven't done so yet, fill out the, do the labeling on page 15 of the diagram. There's a whole bunch of labels for you to do. How many labels are there for you to do? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15 labels for you to do. So if you haven't done them yet, do them now. This picture will help you out tremendously. Okay. What we need to do now is take a slight detour and talk about membranes. Body cavities are always lined by membranes. And membranes can help attach organs within their cavity. It can anchor organs. Membranes can also provide a means of reducing friction between organs. When organs are adjacent to one another and there's a possibility that they could rub together, we don't want friction. Friction is our enemy. And having membranes, and these membranes in this case will be moist membranes. And so membranes can help with lubrication. Okay, we have cut open a skull here. And so we're looking in the dorsal body cavity. In particular, we're looking in the cranial cavity. And the cranial cavity has the brain in it. And what we're going to notice here is we can see some membranes that are being kind of like peeled away from the brain here. So this is a membrane right here. This is a membrane right here. Both of these membranes are examples of ones known as meninges. There's actually a total of 3 meninges that are going to be around your brain and also around your spinal cord. So organs in the dorsal body cavity are going to be lined by the meninges. Those are the membranes in the dorsal body cavity. And we can see 2 meninges right here. The primary function of the meninges is going to be to anchor the organs, giving them protection as well, providing a route for blood vessels to go also. All right. So that is good. That is good. Let's keep on going. Oops, I meant to clear all that before. There we go. There we are. Cleared all that. So now we got to talk about the ventral body cavity. And this gets a little bit more complicated. And we have a helpful analogy here with a balloon and a person's fist. So before we get to the balloon and the fist, in ventral body cavities, so thoracic, abdominal, pelvic, etc., organs there are going to be associated with these membranes called serous membranes. The word serous means that they make a fluid. The word serous means they make a fluid. And why would you want to make a fluid? Well, we mentioned this earlier. Or we hinted at it at least. Moist membranes are going to be good for lubrication. Okay? So, if you're in a ventral body cavity, an organ in a ventral body cavity is going to have a membrane around it called a visceral serosa. So if you imagine the fist is an organ, This layer of balloon right here, like directly touching that fist, is going to be the visceral serosa. And then a little bit superficial to that, you would have another membrane called the parietal serosa. So this layer of the balloon right here, that would be the parietal serosa, okay? Notice it's the same balloon. Everything is connected here. It's just different spots on it get different names. And the cool thing about this arrangement is you end up with this space in the middle here. The space in the middle is known as a serous cavity. And in our organs, that serous cavity is filled with a liquid called serous fluid. And that liquid is going to lubricate these two membranes and allow them to move a bit. Think about your heart for a second. Your heart has got to be able to expand and then contract, right? Fills up with blood and then squeezes. That's movement right there. The enemy of movement is friction. And we eliminate, or not eliminate, but we reduce that friction by having this arrangement where we have a double membrane with fluid in between. The inner of the two in the double membrane is called the visceral serosa. The word visceral means guts. So the thing on the actual organ, kind of makes sense, is the visceral serosa. The outer layer is the parietal serosa. Parietal means wall. So you can think about it as being like the outside wall. And serosa refers to the fact that these membranes make a liquid. And we find that liquid in this space here. The liquid is called serous fluid, and the space is called the serous cavity. Okay. I know I'm throwing a lot at you here. We're almost done. Don't worry. Couple little more things, all right? Because we got multiple organs that are going to have this situation. So we might need to be a little more specific. For example, got a heart right here. And here we got a heart in the person's chest. See that heart right there? And we have a depiction of its serous membranes around it. Notice how it looks kind of like what we just saw with that balloon. Look at that heart right there and how it has two layers around it. And then go back for a second. Go back with me here and see how the fist has the two layers of balloon around it. Okay? So, in this heart here, around it, there is this first layer right there. The black arrow is pointing at it. That layer just outside the heart, the inner of the two, is called the visceral pericardium. It is an example of a visceral serosa. So because it's around, peri means around, cardium means heart. So because it's around the heart is the visceral pericardium. The outer membrane, let me put a green dot on that guy, red arrow pointing at him, that's the parietal pericardium, the outer layer around the heart. The space where that little yellow line is the serous cavity, which in this case is the pericardial cavity, is going to contain fluid, which is pericardial fluid. And its major function there is for lubrication. All right. So the heart here is surrounded by a double membrane. Inner one is the visceral pericardium, black arrow. Outer one is parietal pericardium, red arrow. Space between, pericardial cavity. In there is a little bit of fluid. So again, notice that the heart itself is not in that space. There's just fluid there. But the heart is definitely associated with it, like we said earlier. If we look at this heart model, this is the visceral pericardium, this outer part here that I'm touching with my mouse and drawing in arrows on right there. If we had a heart model, you could actually touch it and say, I'm touching the visceral pericardium. All right, good stuff. Let's go on to the lungs. It's going to be a very similar situation. Here's a lung. Directly around the lung, we've got a visceral pleura. A little bit farther out, we've got a parietal pleura. Space in between those two, where I'm drawing my green squiggly, is the pleural cavity. And that pleural cavity would be filled with pleural fluid, which would lubricate. Over here in the lung model, this is the visceral pleura that we can see, the lobulated one right here. All right, that was quicker because we did the heart already. Makes the lung one easier because it's very analogous. Okay. Now we got to take a little trip down inferior to the diaphragm and look at the abdominal pelvic cavity. We got a sagittal section of the abdominal pelvic cavity here. We see a lot of organs. There are a lot more organs we're dealing with right now, so things are going to be a little bit different, but also very, very the same. Okay, what I want you to notice is that each of these organs in here, I'm going to point them out for you. The liver, the stomach, the large intestine, and all these guys are small intestine. Each of these guys has a blue line around it. That blue line is a visceral serosa called the visceral peritoneum. Then if we go out a little more, I want you to notice this green line a little farther out. This green line, kind of against the abdominal wall, against the inferior surface of the diaphragm, against the posterior abdominal wall as well. That green line is known as the parietal peritoneum. Now in between them, we have space. You see some yellow stars I've put in here to indicate that space. And that space is the peritoneal cavity, which will contain the lubricative fluid that's known as peritoneal fluid. Now, one thing we got to notice here is that we have a lot of organs here, and these organs need to be anchored in place. So I want you to take a look and notice we have anchors. These purple guys here, the red guy here, the gold guy here, the blue guy here. These are all anchors. They're actually a double layer of membrane, and they're anchors for these abdominal organs, and they are known as mesenteries. We didn't need mesenteries with the heart of the lungs because we didn't have lots of organs that were within the same associated cavity. But we need it for the abdominal pelvic region. All right, amazing. We've done a lot of good stuff so far today. If we look at this view, got another view here. What kind of section is this, by the way? What kind of cut did we use to make this? If you said transverse, you are totally right. So a lot of organs have been removed just to show you the situation. But check out that small intestine right there. That small intestine has a visceral peritoneum around it right there. Visceral peritoneum right there, VP. And then against the body wall, look at that line right there. That is the parietal peritoneum. And we can see that mesentery anchoring it together. All right. Good stuff, good stuff. This means we're almost done. On page 17 of your lab manual, you are asked to build a model of the stomach, the peritoneum, that's the plural of the two membranes, and the mesentery, using a lima bean and some tape. You don't have to use a lima bean. You can use anything, like any little thing will work. You could use whatever you have at home. If you have a marble, if you have a raisin, if you have a button, if you have a penny, a quarter, a dollar coin, whatever you got. I actually made a video about doing this, and then there's a link to it in Blackboard, so check that out as well. And guys, we are done. Lab number 2. All right, it's been fun. I'll see you next time. Bye-bye.